So for this one, I was going to show you how the PNP transistor works, but the transistor's bad on this. So what I'll end up doing is I'll show you how to diagnose a bad transistorized circuit on this. So this is actually a good technique to learn how to troubleshoot any electrical circuit. This just happens to be a transistor. But before we get into the diagnosis, let me explain how this one works. So if we got our power source here, and the power runs down through here, it comes into the emitter, and then it goes out the collector, because this is a PNP, so it's going to be on the positive side of the circuit, and we use negative to trigger or to turn on the transistor. So the positive side of the circuit goes through the emitter, the collector, which is opposite of what the other transistor did. This circuit goes through here, goes through the fan, goes over here, goes to ground down here. So there's your fan circuit right there. Now your control circuit or your switch circuit is going to be on your base. So we're going to have to supply a ground up to the base in order to turn on the transistor. So if you look at the bottom down here at the ground and you come up here and you follow it right up here to through the switch, and here's that resistor on the base, and there we go right into the base of the transistor. So with the power switch turned on like it is here, we should be able to turn this switch and the power or the fan should come on, but it's not coming on. So there's a couple of ways that we can do this. The first way I'm going to show you is the easy way, and it's using a test light. So this is just a simple, I like to call them scope on a rope. So we're just going to connect this to ground. So let me move my camera down so you can, I'll back it up just a hair so you can see where I've got my thing. So this is just a ground for the circuit. And so I've got my lead hooked up to the ground. So what I'm going to do is I'm going to check for power. So I've got power here. The light turns on. I've got power here. So the fuse is good because I got power on both sides of the fuse. I'm going to come over here and I've got power down to the emitter and no power after coming out the collector, which makes sense if this switch isn't turned on. So I'm going to come over here, no power here. Got power here, no power here. And then if I continue on down the circuit, there's no more power all the way down the circuit. So I'm going to turn the switch and see if that changes. Nothing changes. Okay, I still have power here, but no power here. Okay, so now I'm going to check my ground side and make sure my ground path is working. So to do that, what I'm going to do is I'm going to take my alligator clip and I'm going to clip it to the positive side of the circuit. So I'm going to clip it to the battery source. Now, everywhere I touch with the test light, it should light up if I've got a good ground. So I'll start down here at the bottom. I've got a, you can just barely see that in the frame. Let me move my camera down just a little bit so that you can see what I'm talking about. Okay, so I've got my alligator clip hooked up to the positive. I touch the ground and I've got a light, which means that I've got a good ground there. So I just work my way back up. I got ground there. I've got ground there. No ground there. So let me turn the switch and see if I got ground. So if I turn the switch on, I've got ground. And I've got ground coming up here. Got ground coming up here. No ground there. So I've got ground here. No ground there. I've got ground here. And here. And you see the fan wants to run when I do that. Okay? So I've got a ground here and then nothing up above it. Okay? So my ground circuit is good all the way up through the fan, up to the transistor. It's good all the way up through the switch to the transistor. Okay, so this is the part that might confuse you a little bit. I've got a good ground here, but nothing up here. And the reason I have nothing up here is because this is a load. This is going to use up the electricity. Okay? So next thing I can do is I can use a jumper wire to give it ground here and see if my fan works. So this is where our good old friend, the power probe, comes in. So I've got my power probe here, and I've got my wires hooked up negative, positive on my power probe. And if you remember from our other previous videos and demonstrations, if you take the rocker switch and turn it down, the green light comes on, which means that whatever I touch, I'm giving it a ground. And if I rock the switch up, the red light comes on, which means anything I touch up here is going to be positive. So if I can go through and check everything just like I did with the other test light. I've got a ground here, and I've got ground here, no ground there, no ground there. Okay, so the reason I don't have any ground here is because this is on the other side of the load. If I come down here, there's a ground. Okay? I can also check for power. So if I check here, I've got power. There I've got power. There I've got power. Nothing here. Is ground over here. So let's give it a ground right here and see what happens. So what I'm doing here is I'm checking to see if I've got a negative at the transistor base. Nothing, well, I do have a negative right here at the transistor base, okay? So if you notice, our results are a little bit different with the power probe than they were with the test light, and that's because this is not an incandescent light bulb. This is actually an electronic. This is what you should be using for an electronic circuit like this. So if I've got a ground here, right, and the transistor is not turned on, then that usually means that I've got a problem with the transistor. So if I go here and give it power, fan works. So that means what this is telling me is this is telling me I've got power down to the emitter, and I've got a ground coming up to the base, which means the transistor should be turned on, but it's not turned on because the power is not coming out through the collector. Because if I give power here to the collector, everything works. So that's how you would diagnose this issue here with a power probe. You can do the same thing with a multimeter and then just use a jumper wire, and you could use a jumper wire to give it power up to here. So I'll show you how that works. So here's a jumper wire similar to the one that you guys made in class. And all I have to do is clip it to the positive. So I've got power here, and if I come up here and touch here, power works, or the fan works. Or if I give it here, it should still work. If I get a good connection on there. So that's how you would verify your problem with a jumper wire. And that's basically all I'm doing with the power probe, is just using the power probe instead of a jumper wire. So anyway, that's how this one works. So again, just to recap, working the two transistors, the PNP is positive, negative, positive, which means that the collector and emitter are going to be on the positive side of the circuit. The base is going to be on the negative side of the circuit. So in order to turn on the transistor, we have to give it ground. And then the transistor turns on and allows everything to work. So that would be a PNP. Now an NPN is going to be a little bit different. So with the NPN, we have a negative, positive, negative. And so this is hooked up on the negative side of the circuit. So it's down here. And so you need to have a negative and then a positive and a negative. So to turn this transistor on, what we're going to do is we're going to supply a power to the base. because it's a NPN. So NPN. So we supply power to the base, it turns on the transistor, everything works. So that's the main difference between a NPN and a PNP transistor. Now in the next video, I will actually show you how to build a transistorized circuit.